So yeah, the main discussion is about rocks and minerals.
Can I screenshot?
Let me first. Yeah, so chemistry, rocks and minerals. So since we are having a test next Friday, around next Friday, about rocks and minerals, I did not finish writing down all the major things about rocks and minerals. I just wrote few things. So if we could have somebody to read the things I wrote down in their respective order. If you want to read, you can, put up your hand and read through. Okay, yeah, Salma, you can read. Yes, Salma, you can read.
What is a rock? Rocks are solid aggregate form of a naturally occurring substance. But my son.
Yes, go ahead.
Is this the only definition the teacher gave? Because
it's the only one I can remember according to my notes, because it's all I can remember when we were studying the rocks and minerals.
Okay, all right. Types of rocks. Igneous rocks, sedimentary rocks, metamorphic rocks.
Okay, next person you can read. Let's have like the whole four of us read. Nisha.
What is an igneous rock? An igneous rock is a rock formed from cooling of lava. Types of igneous rocks: extrusive igneous rocks, intrusive igneous rocks. What are extrusive igneous rocks? These are rocks that cool on the Earth's surface, e.g., obsidian. Then intrusive igneous rocks are rocks that cool beneath the Earth's surface, e.g.,
Hannah, you can read. You're next.
Differences between extrusive igneous rocks and intrusive igneous rocks. Extrusive igneous rocks are rocks formed on the surface of the earth. Mama, I'm carrying a bed. I'm carrying.
Yeah, Hannah, are you still on? Hannah. Okay, let me take a position in reading. Difference between extrusive igneous rocks and intrusive igneous rocks. Extrusive igneous rocks are formed on the surface of the earth, while intrusive igneous rocks are formed beneath the surface of the earth. The second is extrusive igneous rocks have smaller crystals compared to intrusive igneous rocks, as they cooled faster. So next type of rock is sedimentary rock. Okay, can you guys tell me the little you know about the sedimentary rock? Yeah, Nisha.
What I know about sedimentary sedimentary rocks. These are rocks formed from weathering, like for instance, the igneous rock or the metamorphic rock is
Yeah.
crushed,
Yes.
and then it's pushed away by the ocean waves or something to the sea, and then it piles up, something like that. It piles up. At times it's mixed with plants, the underground plants,
Yes.
and yeah, it piles up to form a rock.
Yeah. That's okay. That's most I have. That's also what I know about the sedimentary rock. And also another thing that I read from one of the videos we were watching was it has layers. So most of our learning is through
Yeah.
YouTube.
Okay. My soon.
Yes. Yes.
That those layers are called something like that. Like those layers are called strata.
Yes.
Like when there are
Strata.
many, there are strata, and then when it's one, it's my soon. I can't hear anything.
Oh, sorry. I never shared my sound. Let me share my sound.
In this video, we're going to be talking about sedimentary rocks. Please make sure to have your rocks flowchart ready, as we're going to be filling in another portion of it today. Let's get started. Of course, as I mentioned, we're talking about sedimentary rocks, the second variety of rocks in our rocks chapter. Please recall that rocks are classified according to the way in which they formed. So, for example, igneous rocks form from the cooling and solidification of magma or lava. Now, sedimentary rocks form in an entirely different way, which I'd like to describe now. The general way in which most sedimentary rocks form is from the compaction and cementation of sediments. Now, there are some words there that we need to talk about. First off, compaction means what you might think: compacting, squeezing together. Cementation means gluing or cementing, sticking together sediments. But that brings up yet another question. So if these rocks are formed from the compaction and cementation, the squeezing and gluing of sediments, well, what exactly are sediments then? Well, sediments are the fragments, the little bits of rock that have been broken down as a result of a process known as
You can write down the definition of sediment.
weathering. Weathering includes wind and ice, running water, etc. So imagine you have a big boulder sitting in your backyard. Well, if you were to somehow magically leave the earth and come back 10,000 years from now, that boulder might look very different. As a result of years of wind blowing against it and ice cracking it apart and water flowing over its surface, it will have broken down into smaller and smaller pieces. That's what sediments are, the small fragments that result from the weathering of rock. Sediments, interestingly, are classified according to their size. So we actually have 6 categories of sediment sizes, the smallest being clay, then silt, then sand, then pebbles, cobbles, and boulders being the largest. So you've heard the term sand before. Now you know that it actually just refers to a size of particle, not a specific material. If you want to know the specific sizes that make sediments fall into any of these categories, you can find that information on page 6 of your Earth Science reference tables. You can ignore the graph portion of this chart as we haven't learned about it yet. However, I'd like you to pay attention to the names of the sediment sizes on the right-hand side that I've highlighted in green. They will tell you how big each sediment is. So let's use sand as an example. For a sediment to be considered sand-sized, it would have to be between 0.006 centimeters and 0.2 centimeters. Anything bigger would be a different type, as would anything smaller. Another example, boulders are considered any sediment that are larger than 25.6 centimeters in size. Now, let's talk about the first type of sedimentary rock, because there really are 3 types. The first type of sedimentary rock is called a clastic sedimentary rock. Now, a clast is actually just a fancy word for a sediment. So these are actually the types that we have already been discussing. These clastic sedimentary rocks form from compacted sediments, and these are generally classified according to their size. Let's take a look at the Sedimentary Rocks reference table. Now, the clastic rocks are the ones that are on the top half. They are also referred to as the inorganic, because they don't involve any living materials, and land-derived, meaning they come from the land. They come from the rock that makes up the land. Now, if you'll notice under grain size, you can see the different size sediments that make up each of the rocks. Composition tells you what minerals you would expect to see. Comments are just important information. And then, of course, you have the names of the rocks and something called the map symbol, which we'll be using more later in the year. So let's take a look at some of these clastic sedimentary rocks, beginning with the first one, conglomerate. Conglomerate is composed of all different size sediments or clasts compacted and cemented together. So you'll have big cobbles, pebbles, maybe even boulders, compacted with small sand, silt, and clay. Notice that the sediments in a conglomerate are rounded out, likely due to flowing water that ran over them sometime in the past. Very similar to a conglomerate is a breccia. Breccia, too, is made of all different sized sediments compacted and cemented together. The difference being the sediments in a breccia are not rounded. They are more angular, pointy, or jagged. Then we get to the sandstone. As you can imagine, sandstone is made of compacted sand grains. Siltstone, made of compacted silt. And shale, made of compacted clay particles. So those are your clastic sedimentary rocks. Compacted and cemented sediments. Now, back to our chart. Let's look at another type. Let's actually look at the other 2 types. We have organic and crystalline sedimentary rocks. For the crystalline, we have things called evaporites and precipitates. And then for the organic, we have what we call biological matter rocks or bioclastic rocks. Let's talk about these, as they are a little bit more complex. First off, the crystalline rocks, seen here on the reference table. So these are under a column that says chemically or organically formed sedimentary rocks. So these are not necessarily from compacted sediments. In fact, the crystalline ones form in an entirely different way. So crystalline sedimentary rocks are known as evaporites or precipitates. And what that means is that they form as a result of some sort of chemical process. Let's take a look at some examples. This is probably the best example. This is rock salt. Now, rock salt forms from seawater, which of course has salt, or halite, dissolved in it. And when that water evaporates, the salt stays behind in the form of crystals. Those crystals are the rock salt. This is why it's called an evaporite. This is also why it's called crystalline, because it's crystals of salt that were left behind after evaporation occurred. We also get other rocks like rock gypsum and dolostone that form in similar ways. Just to mention the precipitate, this is a similar process, however, as the name implies, it does not involve evaporation like rock salt does. A precipitate forms when a water sample is completely filled with a dissolved mineral, so much so that the mineral falls out of being dissolved and crystallizes in the bottom of a body of water. To summarize, the crystalline rocks all involve some sort of chemical process, whether it's evaporation or precipitation. The result would be rock salt, rock gypsum, or dolostone. But what about these biological rocks, the bioclastic rocks? Now these form from compacted organic material or organic matter. We already know some examples of these, which include coal, which forms from compacted plant remains, and then this, which is a variety of limestone called a coquina. And you'll notice this is made of compacted shells. Shells, of course, are made by sea creatures. This is organic material, and so being classified as a bioclastic rock because it's organic matter that's been compacted together. One more key note about sedimentary rocks is that they are the only type of rock that may contain fossils or evidence of past life. So if you see a rock with a fossil in it, you know automatically it must be a sedimentary rock. The reason being, the processes that involve the formation of igneous and metamorphic rocks involve a lot of heat and or pressure. And so these processes would destroy any fossils that existed. Therefore, the only type of rocks that really commonly contain fossils are sedimentary rocks. We'll learn all about this in school. Thanks for listening.
I hope you have not.
If you want to achieve better results, make a great impression, and save time at work, you should get.
In this video, we're going to be talking about We'll learn all about this.
In this video, we're going to talk about weathering, erosion, and deposition. Let's begin with some simple definitions of these three terms. So, weathering in this sense is the breaking down and changing of rocks as a result of exposure to the environment. So if I have a large slab of granite in nature, and over hundreds and thousands of years the waves of the ocean are crashing onto that rock, inevitably the rock is going to break down into smaller pieces, it might get rounded out, it's essentially going to change as a result of exposure to its environment. And that's just one example of what weathering can be. There are lots of different types, and we're going to look at those in this video. After rocks are weathered, they are often eroded, and that process erosion is the transportation of the sediments that have been broken down by weathering. So if you imagine little bits of granite being pounded off of that slab because it's being hit by wave after wave, and then being carried away in the ocean current to a different location. Well, the act of carrying those little chunks of granite, those weathered sediments from point A to point B, that is erosion. Erosion is all about movement and transportation. The final part of the process is called deposition. So deposition is the dropping off of the sediments that have been weathered and eroded. So to continue my example, if those little tiny bits of granite broken off and weathered by the waves and then eroded or transported by the ocean currents eventually get deposited on a coastline many hundreds of miles away, that is deposition, the dropping off. And so to kind of summarize this and some of the other key ideas, we're going to use this surface process flowchart, which is available on the website. And we'll begin by filling in the 3 boxes on the top to kind of summarize these 3 main processes, starting with weathering, which we know is breaking apart of rock, and then erosion, which is the transportation of the sediments, and finally deposition, or the dropping off of those sediments. So another way to think about this is just kind of a quick analogy that kind of helps me remember the differences between them, is that weathering is kind of like nature's hammer, right? It's Mother Nature's way of taking big bits of rock and smashing them into smaller bits or changing them into something new. And then erosion, in this example, would be something like a dump truck or a pickup truck carrying all the little bits and pieces broken apart by weathering from one location to another. And then deposition is that dump truck kind of opening its tailgate and dumping everything out into a big pile on the ground. That's deposition. So that's just kind of a helpful little way to remember the differences between these 3 parts of this larger weathering, erosion, deposition process. Now, for the rest of this video, we're really going to focus on weathering specifically. And we're going to start by looking at the 2 main types of weathering. And the first example we're going to look at is called physical weathering. Now, I just want to point out that physical weathering is also often known as mechanical weathering. Okay, so physical and mechanical are the same thing. And this would be the breakdown of rocks into sediments. And the key is that it's without changing their composition. So this is literally changing size and shape of a rock. So the waves crashing against a boulder and breaking it into small pebbles that might be rounded out. That's physical or mechanical weathering. But it's still granite. It's not changing the rock or what it's made of. But that does also happen in nature, and we have a different name for that. That's called chemical weathering. And so this is when the rocks are changed chemically because of some reaction with usually something like air or water in nature. So the altering of rocks as a result of exposure to different substances. So let's add this information to our flowchart. So we're breaking down weathering into 2 smaller types. The first is physical or mechanical weathering, which is breaking, cracking, and grinding, things like that. And we'll see examples of those shortly. And then chemical weathering, which involves some sort of reaction that changes composition. So that's a really key difference between the 2 types of weathering. So let's dive a little deeper into our physical or mechanical weathering and look at some different examples. For our purposes, we're going to break this into 4 specific types: frost action, exfoliation, abrasion, and root wedging. So we will start with frost action, which, by the way, is also known as ice wedging. There are a lot of different names for it. And as you might imagine, this involves ice. And so what happens is, take an area that maybe it's a little bit above freezing temperature during the day, and you get some rain or maybe some melting snow, and you have some water that seeps into the cracks within a rock, right? And then the sun sets, and inevitably the temperature drops, and that water freezes into solid ice. Now, you may know already, when water freezes, it expands slightly, and it gets a little bit bigger. And so as it expands, it's going to be pushing outwards on the rock that it has seeped into. And that force, believe it or not, is actually strong enough to very slowly and gradually break apart rocks. And this process is known as frost action or ice wedging. And so we see examples of this in all sorts of areas where the temperature is a little bit above freezing during the day and then below freezing at night. And in fact, a good example of this is what we call a pothole, which you see all over the streets, particularly in the northeastern United States in the springtime. When you have these big fluctuations in temperature, the water actually gets into cracks in the road and then freezes and expands, and then you drive over it the next day and it just breaks apart and you end up with these big nasty holes in the ground. That's a good example of frost action or ice wedging. Second would be exfoliation. And this is, in a way, kind of similar. This involves temperature changes as well. So this occurs in areas where you have really dramatic temperature changes, where it gets very hot during the day and then very cold at night. The rock itself will actually expand slightly in the heat and then contract in the cold. And if this happens day after day, night after night, it weakens the outer layers of the rock until they eventually begin to crack and peel apart like this or like this right here. It's almost like the rock is shedding its outer layers and physically or mechanically breaking apart, largely as a result of these temperature changes. Third example, which is the most common, and we see it all over the world, is called abrasion. So abrasion is basically whenever rock grinds against other rock. And it comes in many forms. Like here in the desert, we see a lot of wind abrasion, where gusts of wind will blow grains of sand that crash into other rock, and very, very slowly over thousands.
Okay, I think that suffices enough. So the thing that particularly I have got from the video is, okay, the first thing was we went to sediments, where we defined them as sediments. Sediments, where we define them as fragments of rock. Sediments are fragments of rocks that have been broken down as a result of weathering, as a result of weathering. And what can cause this weathering can be wind, it can be wind. It could be ice. It could also be running water. So yeah, but another thing, there were like 6 categories of yeah, Selma.
These words in brackets, wind,
Yes.
ice, and running water, like, are they examples of how rocks are weathered? Like, what
No.
do they mean?
What they mean is that, okay, like the weathering, okay, what causes this weathering? It's a result of okay, how does this weathering affect, okay, like according to the video, how does, what kind of weathering, since weathering is the breaking down and changing of rocks as a result of exposure to the environment. So what causes this weathering? Is it, what causes the breaking down of rocks? Is it the wind? It could be the ice, it could be the running water, as we described in the type of physical weathering, which was frost action, which was due to ice. So do you get that?
Yes, thanks.
You're welcome. So another thing was summarizing the 6 categories of sediment. 6 categories of sediments. They were according to sizes. Sediments. The first was the boulder. I may get the biggest. Sorry. The next was the cover. Then the pebble. There was the pebble. There was sand. There was silt, and there was also clay.
Clay.
Yeah, clay.
My
Then,
son,
yes.
that second word, like the second biggest, is it supposed to be like CO?
Oh yeah, Koba. Sorry, typing
And
error.
then LE, not
Yeah, LE.
yeah, LE at the end. Koba, like I remember,
It's like this. I think it was Koba.
right?
Like this.
Koba.
I don't remember. I think it was Koba like this. Let me try rewinding the video. And I check. One, do you mind?
My son, I think it was in the first video you shared.
Oh yeah, no wonder I can't find it. Let me try and check whether it would be there.
My son,
I write a lot of essays for school, but I also write sales descriptions for my Etsy shop.
I use Grammarly on my work emails.
In this video, we're going to be talking about
Yeah, it was Kobo. Yeah, Kobo. Yeah, I had somebody call me. Okay. So there was types of there were types of sedimentary rocks. The next thing we looked up at were types of sedimentary rocks. Sedimentary rocks. Sedimentary rocks, and we went ahead where there were three types, which were briefly clastic sedimentary rock, clastic. There was organic. It was actually called compacted organic matter. Compacted organic matter. There was also
bioorganic, I think.
Yeah, the organic part we are done. It was, I think, crystalline. Was it crystalline? Crystalline or something. It was, I think, crystalline. Where the evaporation and precipitation. Crystalline. So yeah. Then we went ahead to look at how those, starting with clastic, if I can remember right. Plastic, it was from compacted sediments. Then it was from compacted sediments. The composition, they were like, there are different kinds of composition. The composition included feldspar. You can find feldspar. Majorly the minerals that are in this clastic type of rock, type of sedimentary rock. You can find feldspar, you can find quartz. Yeah, it was mostly quartz. Mostly quartz.
My soon on quartz, isn't it supposed to be Z, not instead of S?
Quartz.